Hello, in this video I demonstrate the functionality of the single and three-phase switch. Therefore I add a switch to my pre-existing network. I ground the switch as well, the same way as the source is grounded. The source is a 100 kilovolt peak voltage source. It starts at the phase angle of 0 degrees. It is cosine shaped. On the switch I want to see the voltage and the current trace. I would start my simulation with a closed switch. I ask the breaker to open immediately after the trigger. I set the trigger to open at 8 milliseconds after simulation start. Let's run the simulation to see what happens. You can see that now the current of the switch is interrupted forcefully after 8 milliseconds and the voltage jumps from 0 to the full source voltage of 100 kilovolts. This time I would like to see the breaker interrupting the current only after current 0. Therefore I tick this box there. And let's run the simulation once again to see what happens. You can see now that even though the breaker still opens the contacts after 8 milliseconds, the current continues to flow until current 0. And only then the voltage across the breaker joins the voltage of the source, which is 100 kilovolt. In reality, however, the voltage across the breaker would not jump after current interruption. There would be a small oscillation, which is called transient recovery voltage. Therefore, I add an RC circuit to the terminal of the breaker. And I would like to have, let's say, start with 10 microfarad capacitor, and the resistance would be, let's say, around 5 ohms. Let's see what happens now. I run the simulation again. I start with a breaker being closed and I want it to open after current 0, to interrupt the current after current 0. Let's run the simulation now again. Let's see what happens, and you can see now that there is now a transient recovery voltage. The voltage across the breaker doesn't jump anymore. I want to increase a little bit the frequency to make it more realistic. And in order to damp the oscillation, this transient recovery voltage, I increase slightly the ohmic resistance of this RC circuit. Now I have a relatively realistic view on such a current interruption. I can also do it the other way around. I can start the simulation with an open breaker and close after 8 milliseconds. Let's see what happens then. I go to the simulation and here we are. The breaker starts open and closes after 8 milliseconds. We can also utilize the breaker as a spark gap. In this case, I would like to have a breakdown voltage at 90 kilovolts. I start with the breaker in an open position. You see the breakdown happens now at 90 kilovolts. I can also simulate the breaker with a very slow contact separation speed. The voltage withstand capability in this case would be 2 kilovolts per millisecond, so it would be very slow. I expect several reignitions. Let's see what happens then. So the breaker starts close. After 5 milliseconds the contact has separated. I have to simulate now for a longer time, 100 milliseconds. And you see now that the breaker opens the contact at around 5 milliseconds, and then there are several reignitions every 10 milliseconds until the breaker reaches full recovery and can withstand the TRV. Now I want to demo the switch with 2 operations in a sequence. So I click on the switch box. On the input form I tick the CO box. And now I see the 2 timers. Timer 1 is for the first operation, timer 2 is for the second operation. So I put the first operation at 15 milliseconds after simulation start, the second one after 30, and I start with the switch in open position. Let's run the simulation now and let's see what happens. So here you can see the switch starts with an open position, 15 milliseconds later it closes and then it reopens after 30 milliseconds. I can of course also do the other way around, that I start with a switch in a closed position. That's what I will do now. So the switch is now closed at the beginning of the simulation, and it opens after 15 milliseconds. That's what I see now. After 15 milliseconds I see the TRV appearing between the contacts of the breaker, and it recloses after 30 milliseconds. There is a very attractive feature to synchronize the start of the switching operations with the transient recorder start. I will explain it in the chapter Transient Recorder further down. Now I would like to demonstrate that what I just showed for the single phase switch works as well for the three phase switch. So I just want to make a three phase arrangement now, which is exactly the same arrangement single phase but three phase this time. So I start with a three phase source, and then I add all LR circuit. I put the same values, 100 kilovolt for the source as I did before for the single phase. So 100 kilovolt, and here I have 60 millihenry and 0.1 ohm resistance. Then I add a switch. The switch this time is three phase, so I just input exactly the same data as before for the single phase. I want to make a little bit a distance between the LR because I forgot to put in the RC circuit, so I create some distance. I reconnect the individual connecting points, and now I add a three-phase CR circuit and connect it to the individual connecting lines. So, and now I ground the whole circuit as I did before for the single phase. And once everything is grounded, I run the circuit, and first of all I have to correct the numbers for the RC circuit. So I have 70 ohms and 1.5 microfarad. And then I should get exactly the same behavior as before single phase, but this time three phase. So let's run the operation and see what happens. So I want to see the voltage and the current, and I want to have the same switching sequence as before, 15 milliseconds and 30 milliseconds. And I start with the breaker in a closed position, run the simulation, and here you will just see the result. So I increase a little bit the accuracy of the calculation. I go to, and you see here I have now only 20 milliseconds. I wanted to see 100, so I correct it. So I want to go to 100 millisecond calculation time. This is what I have now. And you see now the breaker opens after 15 milliseconds and recloses after 30 milliseconds, but this time in a three-phase sequence. There is also a possibility to randomly open or close the switch. It works in both single and three-phase. I want to demonstrate you the input form for such a switch. So I select the switch with this clock symbol, and here is a three-phase switch, and I can add a timer there, and that means that importantly during continuous operation the switch will decide whether it opens or closes after the timer which I put here, 1 second. So every second it will decide should I open or close randomly.